Hello, this is Mr. Agbamu Idanogrene. I'm here to teach you how you can get the basic rule of differentiation. In my previous video, I showed you how you can differentiate a function from first principle, and we did all the basic introduction to it. You saw how we introduced delta y over delta x. Then from there, we now use limit of a function to convert the final function now to divide the x to get the answer. So in today's class, I want to show you how you can differentiate a function easily using the basic rule of differentiation. So when, for example, if I have a function like this, let's say y is equals to x raised to power n. So let's say I have a function of this type and I want to differentiate it. So how do I differentiate this easily without going through that step of first principle? But for me to show you how to differentiate it easily without going through the stress of first principle, I still need to use first principle to demonstrate it, so that with first principle you will know that we are not just doing some manipulation in our calculation. It is the first principle of differentiation that guides us in everything we do. So that is why when we differentiate some functions in differentiation, sometimes some students may say, how did you get this answer? They'll be asking us, the teacher, how did you get this? But they don't know that we use first principle to do it. But since from first principle you can derive basic rule, why always using first principle? Why not just use first principle to derive a rule, then start using that rule in your differentiation? So to start now, you know how we do our differentiation from first principle. In the next step, we introduce delta y in this value of y and delta x in the value of x. So I'm going to have now, which is y plus delta y. The y plus delta y will now be added to y, then equals to, then you open your bracket, because x is raised to power n, so n is outside the bracket, it's not part of x. So which is x plus delta x raised to power n. So this is the first thing we do. Then what next? The next thing is we need to expand this bracket. But if you look at the expression here, n is the power. We don't know the value of n. So the only thing that can help us in this expansion now, we need to use our knowledge of binomial expansion. That is the only way we can use to expand this. So how do we do with binomial expansion now? Let me just recall our binomial expansion in case you have forgotten it. You know that binomial expansion, in binomial expansion, when you have to expand a function like this, x plus delta x raised to power n. Let me demonstrate it here with my pen here. So what you do first is you pick the higher the power now outside the bracket, which is n like this, n, then n combination. Remember this is symbol for combination, permutation and combination, this combination, so n combination. Then you always start with 0. So but most time, let me use r to demonstrate this. Let's say n combination r. So you know that r is a set of numbers. So r is equals to from 0, 1, just like that, 2. So r will keep going until it gets to this value of n. That is when you stop your expansion. It keeps going until you get to n. So that is that. So if you are starting the expansion of this now, you start with n combination 0. You keep going till you get to n combination n. That is where you are stopping. So that is when you know this value of n. So if n were to be 2, for example, so it will be 2 combination 0. Then the next term will now be 2 combination 1. Then until you get to 2 combination 2, that is when you are stopping. So that is binomial expansion. You understand that when we get to the topic, binomial expansion. But for now, let's use the knowledge in basic rule of differentiation. Then the next thing you do is you take the first term of the bracket now, which is x. So you have your x now will now raise to power n minus r. N minus r, that is the rule, which is n minus r. So take note of that. Then it will now be multiplied by delta x raised to power r. The value of r here will be the power of delta x. Then you have delta x now raised to power r. So take note of that. So this is what we are going to do in this expansion. So with this knowledge, we'll do the expansion and we'll get our result. So take note of this, is very, very important. Alright, so to start now, what I need to do now is I'll move on to the next step now, which is y plus delta y will now be equals to, so when we expand this, the first term, you know, n combination 0 is the first term. So you already know that n combination 0 is going to be n factorial divided by r, which is 0 factorial. Let me just type it so that you see it well. So this will give us n factorial divided by 0 factorial, then multiplied by n, that is n minus 0 factorial, which is n minus 0 factorial. So this is what you are going to get in the first step of the expansion, which is the value of x, that is n combination 0. So this is what you are going to get. And if you simplify this, you discover that n factorial will be in numerator. 0 factorial is 1. When you check with your calculator, it will give you 1. Then n minus 0 is n factorial. So n factorial divided by n factorial, at the end of the day, your answer is 1. So the coefficient is 1. So you are only left with x raised to power n minus r. And what is r? You are picking the first value of r, which is 0. So which is n minus 0, which is x raised to power n. So my first term of my expansion here is going to be x raised to power n. So that is that. Then we go to the next term, plus, then you know, if you check this first term also, delta x is raised to power r, and r is the first number we are picking now, which is delta x raised to power 0. So any number raised to power 0 is 1. So that's why everything here is 1 apart from x raised to power n. So the first term has been expanded. Let's go to the second term. So what will be the second term? Now r is now going to be 1. So if r is going to be 1, this place 0 factorial will be 1 factorial. Then this place is now going to be n minus 1 factorial. If you take note of this, then if I simplify this one further, you will discover that it's going to give us n. You know, n factorial, you know the rule for factorial, you keep multiplying downward. Like if I have, for example, 3 factorial, you know that 3 factorial is equals to 3 times 2 times 1. You know, this is what we do in factorial. You are subtracting 1 from the number. So 3 minus 1 will be 2. 2 minus 1 will be 1. So this is what we do in factorial. So the same thing here. If I subtract 1 from n, it will now be n, open bracket, n minus 1. Then I'll need to stop here. Factorial. So if I keep going, n minus 1 minus 1 to give me n minus 2. But I need to stop here because of the denominator that I have there. So divided by, so 1 factorial is 1, so we ignore that. So divided by n minus 1 factorial. So you can see that when n minus 1 factorial cancel out, you can see it now. So if n minus 1 factorial this cancel out n minus 1 factorial, we are left with n. So the constant that will come here first is going to be n. So you put your n here. So you have n. So we are through with simplification of the factorial. Then the next thing we said n minus r, so we are in this place now, which is n minus 1. R is 1, which is the second term. So this place will now be x raised to power n minus 1. So that's what you put down here. Then to end our work now, we say delta x will now raise to power r. And what is r? 1. So delta x raised to power 1. So this place will now be delta x raised to power 1. So we don't need to put it there. So no need. Power 1 is the same thing. So if you keep going with this expansion, if you go to 2, you know n, we don't know the value of n. You will keep expanding just like that till you get to the end. So instead of keep going like that, what I just need to do now is put my dots, just to put your 3 dots to tell you that the expansion will keep going, and just like that. So that is that. So I have plus dot dot, so just like that. So the expansion keep going and going till you get to delta x raised to power n. So this is where you are going to stop. So you take note of this, very, very important. So take note, it's very, very important. So that is what I've been trying to say. You keep expanding with each value of r until you get to the value of n. That is where you are stopping. So if I keep expanding this, since I don't know the value of n, if I keep expanding, I'll keep going until I get to the value of n. So when I get to the value of n, when n equal n, so I'm going to have n combination n, which are the same number. So n minus n in this place, you know, is going to give me 0. So and this place is going to be n also. You know, n minus n is 0. So 0 factorial is 1. So n factorial will cancel n factorial. You see why everything here will be 1. Then x will now be n raised to power n minus n. So n minus n, at that time this point is going, this place n r, which is going to be n. So n minus n will be 0. So x raised to power 0 is 1. So you are left with the x raised to power r. As in this last term, r is equal to n. So that is why I just put it down like this. That is it. So I hope you get this place very well. Please just go through this explanation that I did very well, so that you know how this step came about. It's very, very important. Then the next step in our calculation is to take y to the other side of the equation, so which is going to be, so when I take y out of this side, so I don't need y in this side, so y is now going to be added to this side of the expression, which is plus y. Take note of that. Okay, sorry, it will be minus y. You know, y is positive in this side. When it crosses the equal sign to this side, it becomes negative. That is negative y. That's what we have down here. So if I move on now to the next step, so my next step is now going to be, so what is the value of y? The value of y is x raised to power n. So I need to take y out of this place and substitute it as x raised to power n. So that is it. Then at this stage, we can see like terms that can go. So x raised to power n minus x raised to power n, these two will cancel out, so they will become 0. So that one will leave the equation, then which will lead us to the next step now. To take us to the next step, let's move up a little. Okay, move up a little. Alright, so I don't need this. Let's take this out. Okay, so at this stage, these two will go now. X raised to power n minus x raised to power n will cancel out, so we don't need them in this side. So this one will go, then this other one will go too. Yeah. Okay. Okay. So that is it. Alright, let me take this out. Okay, so this is what we have now. Then at this stage, what next? We need to divide both sides by delta y. Then when we divide both sides by delta y, we are going to end up having this. So that is the next thing we need to do now. So dividing both sides by delta y, so this side will now be divided by delta x. So you are dividing both sides by delta x, not delta y. So this is going to be, let me arrange this place very well. Okay, this place is going to be delta x. So when you divide both sides by delta x, you are going to get this, and this will lead us to the next step now. So delta x is going to cancel out this delta x, then delta x is going to cancel out delta x here. So since you don't know the value of n, so we end up as, but we all know that this value will now be n raised to n minus 1. You know this is having minus 1. Let me just demonstrate it in the next step so that you get what I'm talking about. So this is what I mean. So the next step now is going to be like this. So delta x, so delta x will cancel out this delta x, so I don't need this one there. This one will go out of the place, so this one will go. So delta x will also cancel out this. So when delta x cancel out this, it will now be n minus 1. So this place is going to be n minus 1. So this is what I'm talking about. Because of rule of indices. Remember the rule of indices? You pick one of the base, then you subtract the power, n minus 1. That's what you are going to have. So how do we end our work now? So finally, my final rule is about to be set now. So how do I get it now? So I'll get my final dy dx now. So dy dx is now going to be equals to dy dx equal to, you need to get the limit of that. So dy dx is equals to the limit of delta y delta x delta y divided by delta x when delta x approaches 0. So what is this limit of this function? So the limit is when delta x approaches 0, you substitute 0 in this place. Then 0 raised to power any number is 0. I know we are adding it plus that, so that is all. You are now left with this value. So finally, the basic rule for differentiating a function is dy dx, which is equals to n x raised to power n minus 1, which is this one. So this is the final rule I want us to learn. So this is the basic rule of differentiation. Take note of this rule, is very important. This is very important. So this is the basic rule of differentiation. When you are asked to differentiate any function, so you can use this, you will get the same result. It's very important. So if I have something like this, for example, they can ask you to differentiate, let's say y equals to, let's say 3x raised to power, let's say raised to power 5. If you are asked to differentiate something like this, instead of you using this long first principle step that I used here and in my previous videos, instead of you using those principles, why not just use this formula? You will get the same result. You can try it and you see that we'll get the same result. So all I just need to do, I'll just say dy dx is equal to, then what does the rule say? The rule says subtract 1 from the power. So the power of 5, the power of this expression is 5. Subtract 1 from 5, so 5 minus 1. So let me just put it down. So I have 3 as a coefficient already. Then I'm going to multiply it by the power 5. 3 times 5. That is what this place means. When you have y equals to x raised to power n. You know that is what we have. This one, let me show you. No, we have y equals to xn. So if you look at the answer we got, the y ds is power n, we multiply the coefficient of x. So that is what we have, which is this. So power n multiply the coefficient of x, which is nx raised to power n minus 1. So that's what we are going to do here. So power n is 5. 5 times 3, then x raised to power 5 minus 1. So this is the basic rule of differentiation. So we don't need to keep using first principle. So that is that. So dy dx now be equals to 15x raised to power 4. So that is the answer of this. So the same thing with y equals to, let's say y equals to x, let's say x squared. If you are asked to differentiate this from first principle, just go straight to the point. The y dx will be equals to 2x. So that is the answer. So by following the rules, the power is 2, so 2 times the coefficient of x, which is 1. 2 times 1 is 2x, then 2 minus 1 is 1. So that is the answer. So this is all I want us to learn in today's class. In our next class, my next video, I'm going to show you how you can differentiate other functions like product, quotient, function of a function, just like that. So I hope you understand all I did today. I just wanted to know how we got the basic rule of differentiation. So with this basic rule, you can differentiate any function, you can differentiate sum of functions, just like that. Just follow what the rule says we should do. The power will multiply the coefficient first, then the power minus 1. So that is it. Power 5 times 3, 15. Power minus 1, 4. So that is the answer. So do have a nice time and take care.